This short video will go over the very basic elements of a simple path diagram for a program. Let's create a path diagram that represents a program. A program is supposed to change something, an outcome. Let's think about a nutrition education program that's designed to reduce childhood obesity. I almost have at least one student in every class who suggests that as an example. So the program is the thing that causes the change, and in our case, that's supposed to be nutrition education. The outcome is what it's designed to change, the effect. And in this case, it's obesity. You also really want to pay attention to what is sometimes called the individual, the who or what is being described. Who or what is this program supposed to affect, and who or what is being affected, the outcome. So in this case, it's a child. So here are the two variables for our path diagram. Here's our program, nutrition education, and here's our outcome, obesity. So each of these ovals represents a variable, and a variable is something that describes the characteristics of our individuals. So these are characteristics of children. Is the child getting nutrition education or not? How much nutrition education? Variables always vary. They can go up and they can go down in both directions. A variable must vary. So we couldn't have child as a variable because we're talking about children in every single case, so we don't have children versus adults. So according to the theory, if you increase the nutritional education of children, as a result, the obesity will decrease. So that means that if we increase nutrition education, as a result, obesity will decrease. That's an example of a causal relationship. In path diagrams, the causal relationships are represented by the arrow, and the sign of the relationship is represented by a minus or a plus sign above the arrow. So notice, of course, the arrow goes from nutrition education, the cause, to obesity, the effect. The arrow doesn't go the other way. Causal relationships go in a particular direction. So does our theory imply that for every single child, if you increase nutrition education, obesity will fall? No. This isn't physics, it's social programs. And so these are theories about what happens on average, probabilistically. So just because you find an opposite example doesn't invalidate the theory. So I've been using the terms program and outcome, or cause and effect. Those are the terms that you see a lot in logic models and in program evaluation. There are actually a whole bunch of terms for the same entities. We have a whole list in page 32 of the textbook. But one that's very important for research, one said, are independent variable and dependent variable. So the thing doing the causing is the independent variable, and the thing being affected is the dependent variable. People often get them confused, but you can keep them straight by remembering that the dependent variable depends on the independent variable. So now it's your turn. Think about a program that's of interest to you, perhaps one you work on, one you'd like to propose. What outcome is it supposed to affect? Often people have a long list of outcomes. For now, we want you to focus on the one most important one, and then just draw your simple path diagram for that program. In the next section, we're going to start using the path diagrams. We're going to explore mechanisms. We're going to look at how and why your program is supposed to work. And eventually that will help you figure out maybe if it won't work, and how to make it better. But for now, just think about your program, your outcome, and the sign of the relationship. If you want more on these same basics, you can go to pages 30 and 31 in my textbook with Greg Van Ryzen, Research Methods in Practice. Thanks. I hope that this was useful.